Today's lab, very, very simple. We're focused on density. Remember the formula for density? Right? That simple. Mass divided by volume. Now, how you get those values may take some creative thinking. Mass is fairly easy to get. I mean, we're going to use an analytical balance. But what if your object is solid? Just put it on the balance, right? You get the mass. What if it's a liquid? You can't pour your liquid on the balance and get your weight. Mass, right? It has to be in a container. So if you're going to get the mass of something that's in a container, what else do you need to know? The mass of the container. Yeah. Right. So if you get the mass of the container first, then you put something in it and then put it on the balance. Again, you get another mass. But that's the mass of your liquid and the container. Right? So this mass then would be the total mass minus the mass of the container. Right? Okay. That was fairly easy. How about volume? You need to know the volume of the object. Right? What if the object is has a regular geometry? Right? You can just measure dimensions, right? Well, we're not going to do it that way. We do have one with regular dimensions, but we're going to measure the volume of liquid and two solids. Okay, the liquid, you just measure it by putting it in a graduated cylinder. So if you pour it into a graduated cylinder, and anybody read it so they know what that material is? Isopropyl alcohol. Okay, so if we put the alcohol in our graduated cylinder, right, say it comes up to here. Right? So you measure this is the volume of your stuff. Put that whole thing on the balance. Well, after you weigh the graduated cylinder, then you can get both volume and mass at the same time. Okay? So that's your liquid. The first solid is a rubber stopper, the number 3 rubber stopper. They're over there on that red tray. Just grab one of them when you get ready to run your experiment. The stopper's kind of a regular shape, but it's not. It's sort of I forget what they call it. It's a rotated trapezoid. So technically you could measure it and determine the volume, but there's an easier way. You need a bigger cylinder. Your 100 milliliter cylinder. So you got this much water in there. So that's your initial volume, right? Drop your cork or the stopper in here. Now you got a stopper down there. What's going to happen to the volume of the water? It's going to go up to there. That's your final volume. So the volume of the stopper is what? The final volume minus the initial volume. That difference in volume is due to that stopper. So there you go. This works great if you have something that doesn't react with water, right? If you drop a chunk of sodium in there, it's not going to work. But that'll work for that stopper. And that gives you the volume. So how do you get the mass of the stopper? Well, before you put it in the water, while it's still dry, stick it on the balance. Right? Everybody remember how to use that balance? push the tare button, make sure it's 0, then put the object on it. Okay. Now there's the third object, they say, is an unknown object. I gave up on that a long time ago. I'm going to tell you exactly what the object is. It's a chunk of zinc, and it's over there in that wooden box, right? And it'll fit in your 100 milliliter volumetric or graduated cylinder, and do the same thing. Just note the initial volume, put it in there, note the final volume, and then before you put it in there, of course, get the mass. The zinc's pretty heavy, right? It's going to go to the bottom fast. So if you drop it from a height, the water's not going to slow it down enough. It might hit the bottom and crack your cylinder. So unless you have a plastic cylinder. If your cylinder's glass, then just kind of tilt it on the side and let it slide down. Okay. That's it. Plus the questions. We had some pre-lab questions in here, didn't we? Yeah, pre-lab assignment. Did anybody do those yet? Did you?
Yeah.
Okay. Number 1, what safety precautions should you take when working with rubbing alcohol? Rubbing alcohol is isopropanol. And, well, the rubbing alcohol you get in the store is 70% usually. Sometimes you can get less than that. But we're going to use pure isopropyl alcohol, 100%. It's in those bottles. I think there are 4 bottles in there, so there's enough to go around. You know, how do you transfer that from a bottle into your tiny 10 milliliter graduated cylinder? Pipette's a good thing, yeah. Or if you have a funnel, you can do a lot, and then you can get the pipette and finish it off to where you want it to be. And there are pipettes in that white box on the second level. Okay. So what are precautions that you take with alcohol? First thing that always comes to my mind when I'm dealing with a new chemical of some kind in the lab. Smell? Okay. Maybe because I'm a man, I don't think about smell. No, I think, will it burn? If it's flammable, that's definitely an issue. But smell, yeah, if it's a noxious odor, that could be a problem. So how do you deal with something that's flammable? You keep it away from an ignition source, right? Ignition source, like an open flame. We're not working with open flames today, so that shouldn't be a problem. Are you going to drink it or taste it? No. Is it toxic? Right? Is it an internal toxin, or is it a skin irritant? You know, that could be. So you need to wear personal protective equipment, like nitrile gloves, when you're working with this stuff. Have your lab coat. You have eye protection. I see some glasses. You have eye protection with you. That's good. Okay. I still have my freebies up here if you left yours at home. Okay. So that answers number 1. Number 2, define the following terms. Okay, density, you can do that one. What's an extensive property? We talked about that before, didn't we? Extensive versus intensive properties. It bears repeating. Extensive versus intensive. Extensive property is one that changes with the amount of material you have. So if you have a bigger object and you put it on the balance, it's going to weigh more, right? More mass. So that mass changes with the amount of material. Volume changes with the amount of material. Intensive property doesn't change with the amount of material. So in our case, our intensive property is density. The density of a material does not change with the amount that you have, as long as it's uniform, right? So we have a nice little cylinder of zinc to measure the volume, and measure the mass, calculate the density. Or you could have one of these ugly looking chunks of, we call it mossy zinc. And you could do that one, just drop it in there and do the mass. And it should be the same or very close to the same density, right? So that property doesn't change, but this one does. Extensive changes with the amount of material. Okay, so the third one, they want you to determine the density of an unidentified liquid. Okay, so the student found that it was 7.3 milliliters and had a mass of 6.52 grams. So what's its density? Just use the formula, right? Yeah, determine the density and then compare it to the chart and then identify the liquid. Okay, that's not too difficult. Let's see. How about what's the mass of 9.5 milliliters of ethyl iodide? Well, remember, this is a formula. It's a mathematical formula. If you know two of those factors, you can solve for the third one. And what they're asking for is what? What's the mass? Solve for mass. Mass equals density times volume. So you look at the problem, do you have the information you need? It gave you the volume. Where's the density? It's in that list on the page before, isn't it? Okay, so you can solve that one. What's the volume of an acetone sample whose mass is 6.95 grams? Let's be sure it's there. Yep, acetone's there. So for that one, you just solve the equation for volume. Right? Volume goes over here, density comes back over there. Okay. Let's see. A collection of glass beads has a mass of 29.33 grams. The beads were transferred to a graduated cylinder containing 13.5 milliliters of water. The volume of the water plus the beads was 25.2. Calculate the density. Right. You can do that one. Right. The volume is by difference. Final volume minus initial volume. And then it's giving you the mass. Just plug it in the formula. Any problems with that? Okay, that's all the pre-lab questions. So you have 3 determinations to do. First one is isopropanol or 2-propanol, same thing. 2-propanol is exactly the same as isopropanol. Identification code of the rubber stopper. Just put number 3. Identification code for the unknown object. Just put the symbol for zinc. Okay, you're going to do duplicate calculations, duplicate determinations. Yes. Well, maybe not all of them. Maybe the first one. And then they have post-lab questions. Okay. Oh. This one might give you some trouble. Let's look at the last page. I'm not sure why the authors put this one in there, but I feel obligated to help you out with this one. The density of water at 0 degrees is 0.9999 grams per milliliter. So water at 0 degrees, density equals 0.9999 grams per milliliter. Okay. The density of ice at 0 degrees is 0.9168. So this is liquid water, and this is solid water at 0 degrees. Okay. Well, let's just look at that. What does that mean? The density of ice is less than the density of water, which means if you put ice in water, what's it going to do? Float. Yeah. The lower density object, put it in liquid and it'll float. So why is that? How did it get that way? If you have the same mass of water here and you change it into a solid ice here, what has happened to make the density different? Well, if the mass is exactly the same, then this is a ratio, this is a quotient. So if the mass is the same, then how do you get this one to be less than that one? That has to be bigger. It has to increase volume in order to get there, right? It's a ratio of mass to volume. So if the masses are equal, say we make it that way. The masses are equal. This one freezes. It's less density, which means that term had to get bigger. You had to increase the volume. And that's unusual. When you go from liquid to solid, usually you decrease the volume when you go liquid to solid. But for water, it's different. Did I explain that one before? What happens is, everybody's seen a snowflake, right? How many sides on a snowflake? 6, always 6. That's because of the way the water molecules arrange themselves at the molecular level when it freezes. They form a lattice like that, with, say, oxygen here and hydrogen, and then oxygen, and then hydrogen, oxygen, and hydrogen. So this would have another hydrogen out here, and this would have another hydrogen here, and this would have another hydrogen here. So these are, oops, no, that's bond. Okay, like that. So these would be covalent bonds in the molecule, and these would be intermolecular attractions. And they form this hexagonal shape. Well, in order to do that, in the liquid phase, they're all just kind of in there together, right, with a certain amount of space between them. But when they form this regular hexagonal shape, they go like that. Got all that free space in the middle. That's where the extra volume comes from. When it freezes, it expands. Okay. So that was the A part. The B part is the one that's going to give you trouble. Suppose you have 250 milliliter container completely filled with ice. What volume of liquid water will form when the ice melts? The easiest way to do that is to ratio the densities. Now, is it going to make less volume or more volume when it melts? It'll make less volume, right? Because it increased the volume to go from liquid to solid. So when it goes from solid to liquid, it decreases the volume, right? So the ratio of the densities, this one divided by this one times 250 will give you the volume of liquid that forms from that ice. So, and the last one says, if the water completely filled the container, say you had a container that's exactly 250 milliliters, and the water is right at the top, the ice was right at the top. So when it melts, what's it going to do? Is it going to spill over? No, it's going to shrink. By how much? The value you get here subtracted from 250 is how much it's going to shrink. Okay? Now go home and try to remember anything that I said. It's being recorded. Right. Okay, so I'll post a recording sometime this weekend. Okay. I shared that screen and didn't do anything with it, did I? Okay. So they're the pre-lab assignments. Let's see, pre-lab. Okay, here's a procedure. So the first one is alcohol. Second one is rubber stopper. And the third one is the unknown object, the zinc ingot. Okay, so there's where you collect your data. All right, I'll let you get to it then.